right, 6.6, part 2, function operations. I kind of wanted to break this into two different parts. We're going to break it into, like we did, the function operations at the beginning, and now we're going to talk about composition of functions. So composition of functions is kind of talked about in this chart right here, and I've got the steps and the guidance right here. I want you to see the notation right there. Okay, the composition of function g with function f is written like this. It looks kind of like a multiplication sign, but it's more of an open dot. Okay, so it's like g, a little open circle of f. Okay, and it's defined like this, like the composition of function g with function f, and here is kind of what it means. I know that function notation doesn't mean a lot to you. It will mean it over here. So to evaluate that, step one, you're going to evaluate f of x first, and then you're going to use f of x as your input for g of x. Those are your steps. Over here are some examples on the right. So let's let g of x equal 2x, and f of x equals 3 minus 6x. So it says evaluate, okay, the composition of function g with function f if for -4. So what I'm going to do first is I'm going to take my input value of -4 and I'm going to put that into my f of x function, since that's what comes second. It's the composition of g with function f. So it's telling me to evaluate function f and then use that for my function g. So I'm going to use that -4 as my input. So kind of here's what I did. I'm saying g of whatever I get for this f of -4 right here. So notice I took the 3 minus 6x. It's right here, 3 minus 6 times the x, which is -4. I really like to do that highlighter. I think I will. So I'm going to highlight this -4 right here so you guys can kind of see. That's my input value right there. Okay. All right. So that's my input value. So that's kind of what I want to point out, is that highlight that -4, and as I evaluate that, -4 times -6 is positive 24, plus the 3 is 27. So then my step 2 is I basically use that answer in my function g of x. So that becomes my x value. So 2 times x is 54. Okay, so here's kind of an example. Let's go ahead and work through it so you can kind of see it in action. All right, so here's our example 1. Let f of x equal x minus 5 and g of x equal x squared. So it's saying, what is the composition of function g with function f? Okay, so here's one thing you can do. I have it all written out here, but one thing we can do is I can come over here. It's telling me there's my input value. So I can put the -3 in right here, and I can solve that. -3 minus 5 equals -8. And then I can take that value and put it in right here for my g of x. Okay? And that -8 becomes, then I do -8 squared. So here I'm just showing you that I substituted -3 in right here for x. I solve that to get -8, and then I'm going to use my g of x function, which is x squared. Well, if x is -8, -8 squared, composition of function g with function f of -3 equals -8 squared, which is 64. Okay? For the next 4 problems, we're just going to do these examples together, and then you'll kind of understand what a composition means. It's relatively simple. So for the next 4 problems, let g of x equal 2x. H of x is going to equal x squared plus 4. I want you to pay attention to the order that we're working this in. So this says the composition of function h with function g. That means I'm going to evaluate g first with this input. Then I will take that answer and put it in for h. So you guys, if g of x equals 2x, I'm going to use that 1, and I'm going to solve for this. Okay, so my g of 1 is 2. So now I'm going to take that input and I'm going to substitute it in right here. Okay, so 2 squared plus 4. 2 squared is 4. 4 plus 4 is 8. So this up here equals 8. I have to evaluate each function separately. Okay, let's do the next one. This one wants to know what h, the composition of h with function g, if my input is -2. So again, I'm going to start with my g of x, which is 2x, and I'm going to put in -2, and I get 2 times -2, which is -4. Then I'm going to do my h of x function, which is x squared plus 4, and I'm going to use this input, okay, -4 squared is 16 plus 4 equals 20. So the composition of function h with function g equals 20 when my input is -2. All right, let's look at this one. What's different about this one? I still have an input of -2, but this time I'm doing the composition of function g with function h. So I'm going to start this time with function h. So my h of x, again, is x squared plus 4. So I'm going to start with that -2. Okay. -2 squared is 4, and 4 plus 4 is 8. Now I'm going to put this into g of x, which is 2x. So I'm going to have g of 8, so 2 times 8. So notice the difference in answer here. When my composition, when I do the different order, I get a different answer than I did on problem B. Okay, and then the last problem, again, it's the composition of function g with function h, but look at my input. It's a. So let's try that. So we're going to start with our h, because that's the variable that I'm using for inside that g. I need the output of h of x so that I can use it for my g of x. So let's start with h of x, which is x squared plus 4. And this time, my x value is a, so I substitute that in. So I'm done. I can't simplify that any further. So now I'm going to substitute my answer into g of x. So this time I'm going to have g of a squared plus 4. I'm going to do 2 times a squared plus 4. I'm going to distribute. So 2 times a squared is 2a squared, and 2 times 4 is 8. So the composition of g with function h of a is equal to 2a squared plus 8.